All right, misleading information. There are 5 common ways writers use graphs to mislead readers. Sometimes they might make the graphs misleading on purpose so that they can make people believe what the writer wants them to believe. Sometimes it's just an accident. They just don't create the graph in a good way for readers to understand what they're trying to say. So let's talk about the different things. So this first one here talks about changing the starting points. We have the same exact information. We have group A compared to group B compared to group C. This first chart makes it look like, let's see what it says underneath. It says starting the vertical axis at 50 instead of at 0 makes a small difference between groups seem massive. So if you look at this chart, you'll notice this one's labeled with 62%, which is what this bar points to here on this scale is up at 62%. And these two are at 54%, which also correlates with this scale over here. But because it's starting at 50, it makes at a glance, look like Group A got 3 times as much as Group B and C. Is that really what's happening? No, B and C only have 8% less than Group A does. So not Group A has 3 times what Group B and C do. So sometimes when I'm debating about whether we should start a graph at 0 or start at another number, that's something we need to take into consideration. Is starting at a different number besides 0 going to make it look inaccurate, right? Okay. Misleading information number 2, choosing the wrong scale. So on the first one, you can see that the scale goes from 0 to 40 on the left side. But on the second one, the scale goes from 0 to 15. Both of them have the years 2019 to 2023 across the bottom. So this graph at a glance doesn't look like much is happening. There's a teeny bit of an increase there, decrease, increase, decrease, math. It's pretty flat, right? But when we use a scale to make us really able to see what's happening, then those changes are more dramatic and we can see that they're happening a little easier, right? So just something to consider. It's not wrong. It just maybe doesn't have the effect we might want it to have if we want someone to be able to see that change.
It's not wrong, but it's accurate.
What's that?
It's not wrong, but it's accurate.
Okay. Sure. Whatever words you want to use. It's not wrong, but it's inaccurate. Don't those mean the same thing? Adam. Okay. Number 3. This is on the next page. Incomplete data. So on this one, our left scale goes from 0 to 30, so that's not the problem this time. But the bottom scale, this one is month to month. This one is year to year. So this one is showing more data than this one is. If we look at where this data fits into this graph, that depends on if 2020 is pointing at a particular point or the overall amount in 2020. Because look how 2020 is gradually increasing, so it makes sense that the overall amount in 2020 would have this increase, right? So this increase in numbers is like right here. Let me highlight it. Kind of like right here in this graph. Well, probably more like right here. So it's increasing just like it is here, but because it's zoomed out this direction, we can see more of this detail, but this one is zoomed out, so instead of seeing more detail, we see more of the overall trend. Now, I'm not sure I would really call this one misleading over this one. This just gives more information. But what if you just wanted to analyze these 4 months? Then this one gives us better information, right? So I kind of disagree with this one being completely misleading. I think it depends on what you're using the information for. But it is good to see the overall trend over several years as opposed to just analyzing what happens month by month. Like maybe, for example, maybe you're checking your finances. And if you look at just this much of your finances, you'll see that you just keep spending more and more money, right? Which is what this shows as well. But then if you look at the bigger picture beyond 2020, I realize we're looking at data in the future, but stick with me here, or maybe this is what you want to have happen with your finances. You want to spend less money so that you can save more money. I'm not saying that that's what this represents. That's just something that popped in my head that could show us why we would want to see the big picture. So instead of just showing that, or maybe it could be weight gain, you know, something that we don't like to have happen. So in 2019, 2020, we gained 20 pounds or 15 pounds from 5 to 20. But then maybe over the next few years, we're going to be able to lose some of that, right? So seeing this big picture is more encouraging than just this little piece of, oh, yep, just keeps going up. Okay, moving on. Oh, I need to scooch down this one first. Okay, choosing the wrong graph. Be very careful using a pie graph or a circle graph because your circle graph represents something out of the whole. That means that the percentages in a circle graph should always add up to 100%. If I add these up, it's much more than 100%. Also, this would be the type of graph to use if you're comparing the teams to an overall amount. Let me think of something like a fundraiser. Let's say 3 teams in our school are doing a fundraiser, and Team A raises 50% of the money, and Team B raises 64% of the money, and Team C raises 38% of the money. First of all, these numbers wouldn't be accurate because they should add up to 100%, right? So then this type of chart would work for something like that. But that's not what this is saying. Maybe these statistics are telling us that Team A won 50% of their games, and Team B won 64% of their games, and Team C won 38% of their games. It has nothing to do with adding them together and getting 100%. It has to do what each individual team did compared to themselves, and which one did the best, right? This compares them all to each other working together on one thing. This is individual team results and looking at them to see how the teams compare to each other. So different types of graphs for different types of situations. Okay, last one we're going to look at is graphs that kind of use something that goes against what we expect it to look like. So maybe goes against tradition. So traditionally we might think of a lighter color representing a smaller density and a darker color representing more density, like more people. So which graph makes more sense if we want to say that California and the East Coast, New York and Illinois, have the biggest populations? Looking at a glance, which graph says that to you better? The left one, where the most populated states are the lighter colors, or the right one, where the most populated states are the darker colors? Which one makes more sense? This one, right? Where the more populated areas are darker. That's just what our brains expect us to see. It's what we traditionally look for. So that makes this one confusing because it's kind of the opposite of what our brains expect. Okay, so this has kind of an explanation of that very thing. Okay, what I want you to do is look at these two graphs for me and make a list of things that you think could be wrong with it. Your list could have one thing, it could have several things. Just you yourself look at the graph and write down anything that you don't like about the way the graphs are presented, and then we'll talk about those together. So if you're watching this video, pause it now. Camera, okay? All right, on this first one, gun deaths in Florida, number of murders committed using firearms. I don't know if you noticed, but the graph is like upside down. The numbers start at 0 at the top, and the big numbers are at the bottom. Which is weird. Like, when do we ever do a graph that way? Then the second graph, the time intervals are different and not consistent. So 1 year is much different than a week, but they're represented the same here. So we have last year, last week, current, but they're the same exact length on the graph. There's other things we could be critical of in these graphs. There aren't really right or wrong answers. Those are just kind of the most obvious things that we could say are misleading in these graphs.